Hello everybody. In this video we'll be coding the Dijkstra algorithm. We have already seen how the Dijkstra algorithm works. We have also written a pseudocode out of it. Now let's try to code it in VS Code. Fine, so I've taken the same graph over here. So this graph consists of a list of edges with the weights. So the format of each and every uh, component in this is node 1 comma node 2 comma weight. Fine, so there's an edge from node 1 to node 2 consisting of a weight wt. Fine, so I'm using the same graph that we have worked upon in the past few videos. The first step among this will be to find the SNC list out of it, right? So let's create the SNC list from this list of edges. So for creating the SNC list, what we'll be needing? We'll be needing a vector of pairs. Right? Why pairs? Because if there's an edge from node 1 to node 2, it consists of some weight also. So we'll be creating a vector of pairs. Fine, let's name it as V. And we also know what will be the size of V. The size of the V will be the total number of nodes that are present in the graph. So that is n, right? So now what we'll be doing, we'll be iterating upon the list of edges. And after that, we'll put the nodes into the SNC list. Fine. So let's iterate upon the list of edges, that is A. We know that the first component consists of n1. Fine, that is the node 1. So it will be I of 0. The second component consists of n2, that is the node 2. That will be I of 1. And the third component is the weight. So let's keep it as wt I of 2. Fine. So what we have to do now is we have to put it into the SNC list. So let's say v of n1 dot push underscore back. I will be putting a pair into it. So a pair consisting of the SN node and the weight. So the SN node of n1 will be n2 and the weight is wt. So as we know that in this graph it is a bidirectional edge. So for n1 if we have added n2, then for n2 we have to add n1, right? Fine. So this is how we create a SNC list out of the list of edges. So now it's very simple. We will be calling the Dijkstra function now. So let's name the function as Dijkstra. What we'll be needing? We'll be needing the SNC list, that is V. The total number of nodes that are present in the graph, that is n. And the starting index, fine, because we know that Dijkstra is a single source shortest path algorithm. So what we mean by a single source, we need to have the initial node, fine. So Dijkstra basically finds the distance of each and every node from the source node. So let's keep it as 0 for now. So now let's get the Dijkstra function. So I will be making a void type of function because I'm not returning anything. I will be just printing the distance array there and then. Okay, so the parameters will be the SNC list of pairs. The number of nodes, that is n, and the starting node, let's name it as st. Fine. So we have defined all the parameters. Now what is the first thing that we do in Dijkstra? We create a min heap priority queue. So let's create a priority queue. So it will be containing pairs, basically the weight and the node, because we have to sort it in the order of the minimum weight. Fine. So we will be needing the node with the minimum weight first. So it is basically the syntax for creating the min heap. And last parameter is the comparator. Fine, so let's name it as priority queue PQ. So by this we have created a min heap priority queue. After that we'll be creating a distance array and we'll be putting all the distances to infinity in the start. So let's create a distance array. The size will be n, and for infinity can put int max. Right, I have created a distance array d with all the values as infinity, that is int max over here. So after that what we will be doing, we will be just putting the first node, that is the starting node, into the priority queue. So what is the wait that is taking place to reach the first starting node? That is 0, right? Because the distance of starting node from itself will be 0. So what I can do is in d of starting, I can put it as 0, and after that I can put it into the priority queue. So pq.push. Fine. I will be putting a pair into it. The pair will be consisting of weight comma the node. So the weight will be, current weight will be 0, comma the node will be the starting node, that is st. Fine. So I will just comment it out also. I will be putting the pair of the weight comma the node. Fine. Cool. So after doing this, what is the next step? We have to iterate till the priority queue becomes empty. So while my priority queue is not empty, fine, what I have to do is I have to pick the node with the minimum weight, that is the top of the priority queue. So I can put it in as node. Let's keep it as pq.top. Fine, and we know that it is a pair, right? So the node with the second part of the pair. We have seen over here that the node is the second part of the pair, that is second now. After that, let's keep the weight. So the weight will be pq.top, the first component, that is the first part. Fine. So now what we have to do, we have to just pop the top element out, that is pq.pop. Great. So the next step will be that we'll be iterating to all the adjacents of this node and checking if the condition satisfies. If we get a value, a minimum value, then we'll be updating the distance array. Right, so let's iterate into the adjacents of node. So I will be iterating in the adjacency list, that is v. So v of node. So what will this adjacency list be consisting of? It is consisting of a pair of node comma the weight. Fine. So I will take a variable as adg node, which is the adjacency node. I can put it as I dot first, right? Because we know that the node is the first part. You can see over here that we have put node as the first part and the weight as the second part. Okay, second part will be edge weight. So let's take the edge weight as I dot second, because edge weight was the second part. Fine. So what is the formula for Dijkstra now? So the formula for Dijkstra will be the weight which we took to reach the node plus the weight we took to go from node to the adjacent node. Fine. If it is lesser than the already stored weight in the distance array, then we can change it to the minimal weight. Fine. So if the weight that I took to reach the node, that is WT, plus my edge weight, the weight that I took to go from node 1 to the adjacent node, fine, that is the edge weight. Edge weight, if it is lesser than the already the distance that I already have in the distance array, that is d of adj node, fine. If this happens, then I can change the distance of the ad, fine, as weight plus edge weight, fine. So yeah, this is the algorithm, and after that we'll be pushing the pair of the weight and the node into the priority queue. So pq dot push, the pair will be consisting of the weight will be weight plus the edge weight, comma the SNC node, fine. So yeah, this is the algorithm. Now what we'll be doing is we will be displaying the distance array. So let's display the distance array. So distance array is D. I will display it using cout. Fine. So let's try to run this. Does this run fine? Okay, yeah. So I have the output as 0, 3, 13, 8 and 10. So this is matching with the distance array that we received in the theory part. So yeah, we have coded the Dijkstra algorithm. I hope you understood what is happening in the algorithm. It's a very simple algorithm. In the next video, we'll be going with the time complexity, and we will also try to use a set instead of priority queue and see that how it can be more beneficial, right? And then we will try to code some questions based upon Dijkstra in CodeChef and Codeforces. So yeah, stay tuned for the new videos.